All right, as we take a look at this one, what we have is a hexagon. This is a regular hexagon, and what we mean by regular is all the sides are equal. When it comes down to it, what we essentially have is 6 congruent triangles. We have 6 congruent triangles. This one is the height of one of those. So as we look at these triangles, 1, 2, 3, 4, 5, and then 6 is the measure of these. We have a full rotation there in the middle. That's 360 degrees, and it's being divided 6 ways, which means each of these triangles has a 60-degree measurement here in the inside. 60 degrees, 60 degrees, 60 degrees. Well, this one has been split in half, so we'll maximize this a little bit. So that 60 degrees that it has actually been split into 30 degrees. So we have a 30-degree measurement here. This is a right angle here, and this would have to be our 60-degree measurement here. So what we have is a 30, 60, 90 triangle. We have a 30, 60, 90 triangle. And on our 30, 60, 90 triangle, we have the medium side. Here's where we have to memorize those 30, 60, 90s and 45, 45, 90 triangles. We also could use a trig ratio here, but if we have an angle measurement of 30 degrees right here and 60 degrees here, our medium side is 9. And remember the way we convert medium to small? Small is equal to the medium divided by the square root of 3. So if we're looking at this side, our medium side is 9 square root of 3. And when I put this in my calculator, what I learned is this small side is equal to approximately 1.96. And remember, this is only from here to here, so if I'm looking for the other side, what I have to do is double that number. And when I double that number, I get 10.3923 if we keep doing decimal places there. So what that means is each of these sides is 10.3923. And since there are 6 of these sides, we need to multiply this number times 6. And we learn that our perimeter is approximately 62.4. We're not always going to be able to do a 30, 60, 90, but when we can, it makes sense to do that. So this one we have a pentagon, and it's a regular pentagon. So we have the 360 degrees for our central rotation. Remember, we are dividing it into 5 equal triangles, just like that. So we are dividing the 360 degrees 5 ways, which means each degree measurement is going to be 72. This will be true for all pentagons. So if you've got a good memory, you can just memorize these things. But again, we have a triangle here, and this is splitting it in half. So the 72 is going to be split 2 ways, which is 36, 36 in each of these sides. Now, we do not have the luxury of using a 30, 60, 90 triangle. So we are going to have to use a trig ratio. On our trig ratio, we'll highlight the triangle that I'm referring to, this blue triangle right there. On this triangle, it would be nice if we knew the length of this side right here. So from the 36-degree angle, we have the opposite side and the adjacent side. So the trig ratio that deals with opposite and adjacent is tangent. So I'm going to go tan of 36. And tangent of 36 equals opposite over the hypotenuse, which is 4. So I'm going to multiply both sides times 4. So 4 tan 36 is equal to x. And 4 tan 36 is approximately 2.906. So this little segment here is 2.906, which means this one is 2.906. So together, they make up the side of this figure. So we multiply times 2, or we add them together. It's your call. And we get 5.812. Well, if that's 5.812, that means this side is 5.812. This one is, this one is, this one is, and of course the one that we tallied up. So we have that value, 5.812, one side times the 5 sides of our pentagon is going to give us our solution of 29.1. So I should have been using my vocabulary as we went through. The first 2 questions dealt with the apothem, which is the connection of a line to the middle of any of the sides. And then what we have here is a line that's connecting the center to one of the angles. So our figure is a nonagon. So a nonagon is a 9-sided figure. We still have 360 interior angles, but this time we're dividing it 9 ways. So each angle is going to be 40 degrees. I'm not going to draw all 9 triangles this time, but I want you to understand that all we need to do is find one of the triangles, and all the other ones are going to be similar to that. So I need to construct a right triangle, so I do that by drawing my right triangle here, and then there's my right angle. So on my right triangle, we have a hypotenuse of 16, and we also just found that this central angle was 40 degrees, which means when we split this triangle right here will have an angle of 20 degrees. The other side's also going to be 20 degrees for a total of 40 degrees. So we need this part of our triangle. So on our triangle, we have the hypotenuse, and we want the opposite. So if we think about that, the trig ratio that involves opposite and hypotenuse is sine. So sine of 20 degrees equals our opposite over our hypotenuse, which is 16. We then have to multiply times 16 to both sides. So we get 16 sine 20 equals our missing side. So x equals approximately 5.47. So this x is no longer unknown. This x is 5.47. Which means this side is 5.47. I say side, I mean part of the triangle is 4.47, which means the entire side is 10.94464 is actually what it comes out to when I put this in my triangle. So we have a nonagon, 9-sided figure, and one of the sides is equal to this value. And since there are 9 sides, we have to multiply times 9. And we get an answer of 98.5 because we are rounding to the nearest tens. So this is how we do perimeter of these figures. And we're going to need the perimeter in order to do the next part, which is to find the area. So the formula for area of a regular polygon is equal to 1/2 the apothem times the perimeter. Now in this case, they've given us the apothem. The apothem is the center of the circle to the center of any side. So our apothem is equal to 20, which is given to us right here. So now all we need to do is find the perimeter. We find the perimeter the same way we do on the last few examples. So in this case, we have a decagon. A decagon is a 10-sided figure. So we are dividing our 360 degrees amongst 10 angles, which means the blue triangle that I'm drawing here is a measure of 36. If I drew 10 triangles, they would all be 36, 36, 36. If I can find the area of one triangle, I can find the area of all of these. But what we know is this. If this is 36 degrees, get rid of this, and we have drawn an apothem, what we have done as well is we've cut that angle in half. So this angle that was 36 split in half is now 18 degrees. We also need the opposite side, which we see here. So the trig ratio we're going to need is the one that is opposite and adjacent. So the trig ratio that deals with opposite and adjacent is tangent. So tangent from our 18-degree angle is equal to its opposite side, x, and its adjacent side, 20. So we need to get x by itself. We multiply both sides times 20, and we get 20 tangent 18. And when we put that in our calculator, we get an approximate amount of 6.498. So this side that we've got here is approximately 6.498, which means this side would be 6.498. Which means the entire side would be this. Now at this point, you actually could just calculate the area of these triangles and then just multiply it times 10, or we can use the formula I gave you from the beginning. I'm going to work with our apothem formula, which tells me this side is 2.996. So let's go back to this formula and see what we can put together. We need to know the perimeter. Well, the perimeter of this figure is 12.996, one side, times 10, because there are 10 sides. So our perimeter equals 129.96. So once we have all our information, we just simply plug that into our calculator. The apothem of 20 times the perimeter of 129.96. When we put this into our calculator, our area is 1299.7. Had we done the area of this triangle we have down here, by the way, other option, I don't care if you use this option, didn't mean to erase, sorry. This is one of 10 triangles. So if you choose to find the area of that triangle, the base being 12.996 times the height, which was 20, when we put this into our calculator, we get 129.96. That would be one of the 10 triangles, so we would have to multiply times 10, and that is, of course, the same answer. I don't care which way you do that, but those are your two options. All right, let's take a look at our last example. Again, this is the area of a regular figure, 1/2 apothem times perimeter. In this case, we are given the apothem again. So the apothem equals 8. So now we need to find the perimeter. This is a nonagon. We've already done this math. 360 degrees divided amongst 9 angles means each angle is 40 degrees. Let's just construct this half triangle here. So we have this figure here. This angle would be 20 degrees, and we are looking for the side here. This would be, again, adjacent and opposite. So we are dealing with a tangent ratio from a 20-degree angle equals the opposite over the adjacent. We could multiply this side times 8. This would be 8 tangent 20 equals x. And 8 tangent 20 equals 2.9118. So this is no longer unknown. This is 2.9118. If you wanted to find the area of that triangle, you sure could, because that would mean there are, since this is a nonagon, this is one of 18 triangles of its like. So you could actually do 1/2 base times height and then multiply that number times 18. But let's go ahead and stick to our apothem times perimeter formula. So if we do that, we get 2.9118 times 2 would be the length of this side. So this side would be 8.236. And since it's a nonagon, there are going to be 9 of these sides. So the perimeter of this figure is going to be 52.4124. Perimeter equals. So now we have all the parts of our formula. Perimeter equals 52.4124. Our area formula is half the apothem, times the perimeter. So the area equals 209.6. this is an interesting, I'm going to write this down just for your benefit here. This does not round up to 209.7. Because even though the 4 gets rounded up to be a 5, remember, only natural 5s round up. A rounded up 5 does not. So our answer would be 209.6. It would actually be approximately that amount because we did do some rounding.